Hi, my name is Dor. In the next 5 minutes, we're going to solve a coding problem together. Our task is to write a function called twins that receives an input string and returns a copy of it where every character is repeated twice. When approaching a coding problem, it's a good idea to break it down to steps in order to figure out a solution. First, let's make sure we understand the task. One way to do so is by going through examples. So we see that when the input is a string ABC, the output should be AA, BB, CC. When the input is A, the output should be AA. And likewise, for any other input string, the output duplicates each of its characters. Now that we understand the task, let's make a conceptual plan for how to solve it. Suppose we have the input ABC. A good algorithm for the task could go by iterating over each of its characters and add it twice to the output. So here we start with the first character A, output it 2 times, move to the next character B, output it 2 times again, move to C, output it 2 times, and we are done. With this plan in mind, let's code up the solution. We'll implement a function in Python. We start by defining the function called twins that receives one argument called input that we expect to be a string. Then we initialize an output variable to an empty string, which will be used to accumulate the output characters. We'll loop over the elements of the input using an iterator variable called lm. For each input character, we add it 2 times to the output. And finally, we return the output to complete the implementation. Now you may think, how can we be sure that the code we wrote actually works? One way to verify that and corroborate our understanding of programming is by simulating a run through our code and examine how it behaves line by line. So on the left side, we have the function definition, and on the right side, we see a function call and the variables that we will track over the simulation, called input, lm, and output. We start at the first line, where input gets initialized to ABC. Then we initialize an output variable to an empty string and start looping over the input. lm gets the first character A, it's concatenated once to the output's n, and then concatenated again. And we repeat this process with the character B and also with the character C. We indeed got the expected output, so we can happily return it back. Generally, we can use a tool called a debugger to run such simulations and pinpoint issues in our code. Alternative ways to ensure its correctness are by following some good coding practices, such as to add assertions statements and that we will run along with the code and verify its behavior. For instance, we can verify that the input and output are indeed of type string, and that the output is indeed twice as long as the input. To make our code robust, we should also always consider edge cases, those tricky inputs and settings that we may haven't thought about. For instance, we should make sure our function works correctly for an empty string that doesn't have any character at all. Indeed, in this case, we will just skip the for loop and return an empty output as needed. To better communicate our code with other people and support collaboration, we should also write documentation to describe what the code does, what inputs it expects to receive, and what outputs we can expect it to return back. So we wrote the code and verify it works. Let's see if there are ways to implement it more efficiently, readably, or succinctly. First, the 2 repeated lines with lm is added to the output can actually be expressed through one line. And in fact, we can simplify this expression further and directly duplicate each character. We can use the add and assign operator to add the duplicated element to the output's end, and can even use a syntactic sugar called list comprehension to loop through the input in just one line of code. Turns out that the whole function can even be expressed in just one line by using another syntactic sugar called Lambda expression. Overall, there could be a variety of equivalent ways to implement the same behavior. Now that we really understood the task, implemented it, and verified our solution, we are ready to tackle some challenging extensions. What would it do if the task was to repeat every character k times instead of 2? In such case, we'll have 2 arguments to our function, input and k, that we could use to support this more general case. And likewise, you can see how just a few modifications are enough to make the function deal with lists instead of strings. Finally, let's analyze our code efficiency. We see that its time complexity is linear at the input's end, since we iterate over it once and perform a constant number of operations per each element. And we can also analyze our function's behavior by writing tests to compare its output to the expected ones. In summary, when approaching coding problems, it's good to follow the steps we've seen today. First, clearly define the task, make a conceptual plan, write implementation, verify it works, refactor and improve it if necessary, and finally, analyze its behavior and performance. While doing so, don't forget our problem-solving tips, including going through input-output examples, adding assertion statements, consider edge cases, add documentation, and write tests. Thank you very much.